Hey guys, welcome to part 2 of plotting inequalities on graphs and finding regions bounded by them. So if you haven't checked out part 1 yet, really do go back and check that out first. Make sure you're really happy with what we did there, because things are about to get a tiny bit more complicated. Okay, so if you're happy with part 1, let's get cracking. So the first thing we're going to need to be really happy with in this video, again, is plotting straight lines, but this time we're looking at functions, so things like y equals x, y equals 2x plus 1, for etc. So we've got 4 lines plotted here. Make sure you're really happy with where they've all come from and that you'd be happy plotting them yourself, because we are going to be doing a lot of this in this video. So make sure you're happy with those 4 straight lines. Now then, there is a cheeky little trick for plotting lines that I want to mention. So usually, to plot a straight line, we want our equation to be in the form y equals mx plus c. So y on its own on the left hand side and everything else on the other side. However, if you come across an equation like this, where we have 3x plus 4y equals 12, if we rearrange that to get y on its own, it's going to look really messy and quite horrible. There is a cheeky trick we can use here. It's called the cover-up rule. So all that we need to be able to plot a straight line is 2 coordinate points. If we have 2 points that we can plot, we can draw the straight line. So when we have an equation like this, we can really easily find the points of intersection with each axis. So remember that the x-axis is really the line y equals 0, and the y-axis is the line x equals 0. So we can use that to find our coordinates of intersection. So to find the y-intercept, well, we're going to be on the y-axis, which means x is equal to 0. So what we can do then is cover up the x term in the equation, which will leave us with 4y equals 12. Then we divide by 4, we get y is equal to 3. Now we're not just covering up the x term, we're setting x equal to 0. 3 times 0 is 0, so that's why we can cover these terms up. And then similarly, to find the x-intercept, we set y equal to 0, so we get left with 3x equals 12, and then x is equal to 4. So that's quite a nice cheeky little rule that we can use to plot lines like that. Right then, let's start looking at inequalities. So example 1, find the region satisfying y is greater than x. So again, as in part 1, our first job is to plot the line y equals x. So that's what I've done here. And remember, if it's a strict inequality where y is not allowed to equal x, then our line has to be dashed. So we want the region where y is greater than x. So everywhere on the line, y is equal to x. So what we don't want here, we don't want the region below the line, because y is less than the value on the line. What we do want is the region up here above the line, so we want everything up there. Now let me just prove it to you. Let's pick a point on the line. Let's go for 3, 3. Let's say we start at 3, 3 then, and we go one place straight up. Then our coordinate would be 3, 4. So the y coordinate is bigger than the x coordinate. Y is greater than x. Jobs are good. Okay, example 2. Find the region satisfying y is less than or equal to minus 3x plus 2. Okay, so again, I've plotted the line minus 3x plus 2. This time, we've got an or equal to inequality, so it's a full line. Now we want the region where y is less than minus 3x plus 2, so we want the region under the line, which rules out all of this stuff up here. The region that we want then is everything under the line down here. Jobs are good. Okay, example 3. Now we're getting two inequalities involved. So we want to find the region satisfying y is greater than 2, but y is less than or equal to 2x. So let's rule out the regions bit by bit. So we want the region, we need y to be greater than 2. So I've plotted y equals 2 here, and it's a dashed line because it's a strict inequality. So we want the region above that line. So that means that we can rule out everything down here. Everything under this line we do not want. So that's ruled that out. Okay. So next we then want the region where y is less than or equal to 2x. So I've also plotted the line here, y equals 2x. It's a full line because it's an or equal to inequality. So we want y to be less than 2x. Now anywhere above that line, y is greater than 2x. So we don't want anything above it. All of this can go bye-bye as well. So that means then that the region that we want is above the line y equals 2, but below the line y equals 2x. So we want everything in this top right region up here. Jobs to get 'em. Okay, example 4. So this time we've got 3 inequalities. We've got y needs to be greater than or equal to -1. X is less than or equal to 3. And y is less than x plus 1. Okay, so let's do it bit by bit. So y is greater than or equal to -1. So I've plotted the line y equals -1, which is this red chap. So we know that y has to be greater than that. So we don't want anything at all down in this region. So that's all gone. Okay then, so next we need x to be less than or equal to 3. So x equals 3 here is this vertical green line. Again, it's a whole line because x is less than or equal to. So if we need x to be less than, we then know we're not playing with any of this stuff to the right of that line. So that all goes as well. And then finally we want y to be less than x plus 1. So the purple line here is the line x plus 1. It's dashed because we've got a strict inequality. Now we want y to be less than x plus 1. So we can also rule out this area above that line then. We don't want any of that. So the region that we want is inside this little triangle here. So that's the region that we want. That is the region where y is greater than or equal to -1, x is less than or equal to 3, and y is less than x plus 1. Jobs are good. Okay, example 5. So again, we've got 3 inequalities. So, first one, we want x to be greater than or equal to -1, but less than or equal to 4. Y wants to be less than or equal to 5, and y wants to be greater than or equal to 2 minus 2x. Okay, so again, let's do this step by step and rule out the regions we're not interested in. So, x has to be between -1 and 4. So I've plotted the two lines x equals -1 and x equals 4. Those are the two vertical red lines. So we know then that our region we're interested in is between those two. So we're not interested in this region here to the right of x equals 4. And we're also not interested in this region over here to the left of x equals -1. So already we've narrowed ourselves down quite a bit. Now we also need y to be less than or equal to 5. So the line y equals 5 is in here. It's this green line. Now we want y to be less than or equal to 5. So we don't want anything above it. So this region up here can go bye-bye. And then finally, we want y to be greater than or equal to 2 minus 2x. Now the line 2 minus 2x is this purple diagonal. Now we want y to be greater than or equal to it. So we don't want anything down here below. So again, the region that we want then is, now it's actually a trapezium this time, because we want this region here. Alright, so we've got a bit of a trapezium kicking around like that. Okay, jobs are good and on with the next. Okay then, the last example for this video. So this time we want x to be greater than or equal to 0, y to be greater than or equal to 0, and 4x plus 3y to be less than or equal to 12. So the x and y separate inequalities rule out quite a big part of our graph. So we need x to be greater than or equal to 0. So we've plotted the line x equals 0, which is the vertical line. The red line is the y-axis. However, on the y-axis, x is equal to 0. So we want x to be greater than or equal to 0. So that straight away rules out everything over here to the left of the y-axis. Now, very similarly, we want y to be greater than or equal to 0. So the line y equals 0 is the x-axis. Now we want to be greater than 0, so that rules out everything as well under the x-axis. So already we're only dealing with a quarter of our graph. Okay, and then we had the inequality 4x plus 3y is less than or equal to 12. So that's the guy. You can use the cover-up rule to find his points of intersection with the axes. Now we want 4x plus 3y to be less than or equal to 12. That means that we want to be under the line. So we don't want to be anywhere above it. So all of this goes bye-bye. And then the region that we are left with is this little triangle in here between the x-axis, the y-axis, and the purple line. Okay guys, that's all for this video. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.